Hello, today our group will be presenting about our final project for computer programming course, which is the skincare analyzer. The objective of our project is to create a tool that reads skincare labels from images, which then automatically detects the core ingredients inside that skincare product and then provide a friendliness score for skin safety. After that, it also suggests the compatible and incompatible ingredient combinations so that you know whether to use or not to use specific skincare products with the one you have at home. So here is the sample of an input that the user will input to our website. Clearly, it is a picture of skincare ingredients label. You can take a picture and then input it into our website, and then the output includes the core ingredients, key properties, functions, average skin friendliness score, what to avoid combining with, what it works well with, and also general recommendation. Moving on to the libraries that we have used in our project. First one, for the image processing, we use OpenCV. And for the OCR, which is optical character recognition, we use Tesseract OCR. For data handling and visualization, we chose Pandas combined with Matplotlib. And for text processing and NLP, we use mainly spaCy combined with the fuzz. And for app building or deployment, we chose Streamlit. And here is what our website looks like. So as you can see, there is this button, browse files, where you can drop your files and then it's gonna analyze. Here's a short demonstration for our project. So you first click browse files and then you add your picture, which is the skincare label, and then it's going to upload onto the website, and then the website will display the summary for your skincare and recommendation. Before we dive into our code, I'd like to give an overview of how our code works together and the overview pipeline. So it starts with the first step, which is the user uploads an image of the skincare label, and then Streamlit then saves it as a temporary file and then pre-process the image using OpenCV. After that, OCR extracts the text from the label using Tesseract, and then the text is then normalized and cleaned. After that, the text, the ingredients are then extracted and fuzzily matched, which spaCy then matches the ingredients against the dataset, which is the CSV file that we've created. And then it gives a final skincare recommendation and also the summary of that skincare. And then lastly, Streamlit displays those results on the clean user interface. Next, we're going to dive deep into our code explanation and all the details of our code. So the first function is called the preprocess image bytes. What it does is about the image input and the process of preprocessing the image. So we use OpenCV to preprocess the image. Firstly, we load and resize the image so that it scales up to improve Tesseract's text detection. After that, it is converted to grayscale. And then the contrast is enhanced so that it increases the visibility of faint printed text. After that, noise is reduced, but it still keeps the edges sharp. And then it converts the image to clear black and white regions optimized for OCR. Lastly, it returns the final image, which is fed into the OCR engine. Next is the function for ingredient text extraction and normalization. Firstly, the function, which is called normalize text, performs heavy cleanup. The first step is it converts to lowercase and also remove new lines. Then it searches for keywords like ingredients or water so that it identifies where the real ingredient list begins. After it's got the place where the list begins, it trims off all the irrelevant text, which is everything that is before the first ingredient. And then it also removes other unwanted characters such as brackets, punctuation, and OCR noises. The next step is it splits the ingredients by commas, creating a clean token list, which is then fed into fuzzy matching. Next is the intelligent matching part. So this is a really useful function since OCR can generate errors such as misspelling some words, having like multiple characters that are like misspelled. So the function that is called fuzzy match takes each extracted token and then compress it into a curated master ingredients list, then find the closest match using process.extract1. So this accepts the match only if the similarity score is higher or equal to 80%, which ensures ingredient names are standardized before NLP processing. Moving on to the recommendation generation part. What this function does is it inputs the ingredients and then it compares whether the ingredients in the list is in the CSV file. If it's in there, it's gonna output the recommendation based on our data set and also state the compatibility or incompatibility with other ingredients. And for the ingredient database lookup, we use spaCy. So the step is, first step, we load and standardize the data set, and then we will get a clean uniform data set ready for NLP matching. After that, we prepare the spaCy phrase matcher, which allows us to detect ingredient names inside the OCR extracted ingredient list. After that, we create matching patterns for each ingredient. At this point, the matcher has a library of hundreds of ingredient patterns ready to match the user's input. After that, the user ingredients are matched against the knowledge base, which is our CSV file. So each match return contains the match ID, the start token index, and the end token index. Then it is extracted and cleaned, wrapped in a set so that all the duplicates are removed, so we get the final list of ingredients recognized both by OCR and our dataset. Then we use pandas to filter the master ingredient dataset. This leaves us with a smaller relevant portion of the database of the user's product. In the last step, we generate a human-readable summary, which are all aggregated from the filtered dataset, and then the message is ready. Now, looking at the deployment part, our main goal was to make sure that the entire Skincare Analyzer project runs smoothly on any server, not just on laptops. So, since the app uses OCR and image processing, we had to install system-level tools like Tesseract and its language packs, also with OpenCV dependencies. Then we set up the Python environment using the requirements.txt file. We installed all the libraries that we used and also downloaded the spaCy language model. And once everything was in place, we deployed the Streamlit app, which hosts the user interface and connects all the backend functions together, which includes the pre-processing, the OCR, ingredient matching, and the recommendation engine. So in the final deployment, the server handles every single thing, and users can just open the browser and then upload a product level image and then instantly get the analysis results. Throughout our project, we have used AI tools and also other references to help us with our project. So firstly, we use ChatGPT to gather the data of the properties of each ingredient in the skincare so that we can generate our CSV file, which is used as the data set. We also use ChatGPT to organize the code and clean up so that it's more readable and more organized. We also looked up at the spaCy website to see more foundation guidance on how to correctly structure the ingredient matching workflow using spaCy, so that was also useful. And for the deployment part, which is the last part, we use both ChatGPT and YouTube tutorials so that we know how to deploy and install everything and support the implementation of the Streamlit interface. Next is our project evaluation. So we have divided our evaluation into 3 parts. The first part is the project implementation, which is 20 points. So for the project completeness, we give ourselves 10 out of 10 because we have presented all the libraries used. We had more than 100 lines of code and also more than 5 functions inside. And the project implemented proper programming concepts such as if, else, list, and also dictionary. For project difficulty, we also give ourselves 5 out of 5 because the process of pre-processing the image and cleaning the text extraction was also challenging for us. And for code quality and appropriateness, we get ourselves 5 out of 5 because our code is well structured and uses a lot of functions to make the code clear and readable. So a total of 20 out of 20. In the presentation part, we would give ourselves 10 out of 10 because we have stated the project's objective and demonstration, and we included explanation on our project and how it meets each criteria as we are doing right now. And the presentation was high quality, and the use of AI was also clearly explained. For the report part, which is 10 points, we have reported and included all required details. The objective was included. The description of input and output is clearly mentioned there, and the details of libraries are included. Also, the explanation of the code result and other relevant references are included, so we will give ourselves 10 out of 10. So total score is 40 out of 40. And that's all for our presentation. Thank you.